This is lesson 5, exercise 5F, applications of matrices. This is for the matrix unit. Prior to this, lesson 4, we looked at matrix multiplication. So this is just a follow-on. We've got a bit more context and you can delve into how matrix multiplication works in conjunction with applications of real life. So, data represented in matrix form can be multiplied to produce useful information. So we'll jump straight into an example. This example here, Fatima and Gaia, they have a store and they have a special sales promotion. 1 free cinema ticket is given with each DVD purchase, and 2 cinema tickets are given with the purchase of each computer game. The number of DVDs and games sold by Fatima and Gaia are given in the following matrix S right here. And the selling price of a DVD and a game together with the number of free tickets is given by matrix P. So this right here is saying that the price of a DVD is $20 and a game is $30. And when a certain amount of DVDs are sold, you will get 1 ticket per DVD sold. So if, without looking at the actual matrix itself, if Fatima were to have sold 2 DVDs in one particular sale, we know that she has obtained $40, 2 lots of 20 to get $40, and she has given away 2 tickets. 2 lots of 1 is 2. Okay, that's a context without using matrix multiplication, but we're going to see how much money they've obtained from the DVD and the game sales, and from those sales that they've have made, how many tickets that they've given out. And this is just simply done by a matrix multiplication, and specifically matrix S multiplied with matrix P. So SP 7, 4, 5, 6. The 7 DVDs and 4 games are sold by Fatima, and 5 DVDs and 6 games are sold by Gaia. This is then multiplied with 21, 30, and 2. And remember, when you apply your matrix multiplication, you get the first row of the first matrix, and you add the products of the first column, of the second matrix. In other words, 7 times 20 plus 4 times 30. So 7 lots of 20 plus 4 lots of 30 will give us $260 sales wise. Then what we're so used to is when we do this matrix multiplication, prior to this, we will use just 1 column, but in this case, we've got another column here, and we've introduced a new set of contexts. In this case, the amount of tickets that are given out based on what their sales were for DVDs and games. In this case, what you would do is you would have to create a new column position for here, and this would be for the tickets they sold. Fatima, because it's 1 ticket for each DVD and 2 tickets for each game, it's 7 times 1, or 7 lots of 1, because Fatima sold 7 DVDs, added to 4 lots of 2. So in this case, this is 7 plus 8 to give us 15 tickets. Once we've completed Fatima's multiplication, we then move to the next row. For Gaia's case, she sold 5 DVDs and 6 games. So again, applied to the cost, 5 times 20 plus 6 times 30. That will give us 280. And then again, 5 times 1 plus 6 times 2. And this will give us 17 tickets. So the question is asked for the matrix product, which we've completed, of S&P, and then interpret this information. So the interpretation part, therefore, Fatima had sales of $260 and gave out 15 tickets. Gaia had sales of $280 and gave out 17 tickets. Now you can use your ClassPad calculator to double check these calculations. And in this case, it's pretty straightforward. We just got to be careful that there is an extra column here. All right, let's move on to the next example. We're also going to introduce a new property, and this property is looking at row and column matrices. So, a row and column matrices provide efficient ways of extracting information from data stored in large matrices. So, in particular, when we want to sum, or when we're summing matrices, this can be done. We can use the sum. Hold on, let me try that again. Summing matrices can be used to sum the rows and columns of a matrix. A summing matrix can be either row or column matrix where all the elements are 1. So, a bit of a confusing paragraph. Let's delve into the context. So, there are 2 rules. To sum the rows of a certain matrix, so m times n matrix, we post-multiply the matrix by n times 1 summing matrix. And rule 2 says to sum the columns of a m times n matrix, we pre-multiply the matrix by a 1 times m summing matrix. Okay, so the 2 important factors is if you want to sum rows, think of post. If you want to sum columns, think of pre. All right, let's get into the context. Let's see what this part here is actually explaining and talking about. So here is an example. Example 2, there are 3 rangers and they completed their monthly park survey of feral animal sightings. In this case, cats, dogs, foxes, and rabbits. And this can be seen in matrix S here. So we've got 3 park rangers, Aaron, Barra, and Chloe, and then C, D, F, R for cats, dogs, foxes, and rabbits. So in this particular month, Aaron cited 27 cats, 9 dogs, 34 foxes, 59 rabbits. This is also applied to Barra and Chloe accordingly. Now, we have got matrix A here, which is 1 row and 3 columns, and it's all just ones. And we've got matrix B here, which is 4 rows and 1 column. Again, this whole column full of ones. And we're going to multiply S by A and S by B, or A by S in this specific example. And we're going to interpret what this information means. So, the first one, evaluate S times B. So we're going to get matrix S and multiply it with matrix B. Now, we know that the amount of columns, in this case, is 4, the amount of rows 3. The amount of rows here is 4, so we know that the multiplication of S and B can be completed. So, what we are doing is taking the first row, multiplying it by the first and only column, and because we're multiplying it by 1, all we're doing is getting 27 times 1, or 1 lot of 27, adding 1 lot of 9, adding 1 lot of 34, and adding 1 lot of 59. And when you add that up, really, you're not really doing any multiplication. All you're doing is adding that row here. So 27 plus 9 plus 34 plus 59 will give us 129. Then we go to the second row for B, for Barra. 15 times 1 plus 15 times 1 plus 10 times 1 plus 89 times 1. Again, all we're doing is just adding that row here to get 132. And again, for Chloe, 35, 6, 47, 29, just adding those up to get 116. So what information about matrix S is given by this product, S times B? Well, what we're doing is just adding the amount of animals or feral animals that each person cited, isn't it? Because Aaron cited 27, 9, 34, and 59 animals all up. Regardless of what they are, that's how many animals we've cited all up. So all we've done was just multiplied it with this this vertical column of ones. We've multiplied it to each of them just to get the sum. So SB gives us the sum of each row in S. Or in other words, the total sightings made from each ranger. Okay, so when we multiply this matrix here with this 4x1 full of ones, we get the total sightings made. Now, same thing applies, but instead of S times B, it's A times S. And remember, this is a pre-multiplication. A is a 1x3 matrix, and S is a 3x4, so this multiplication can be carried out. And so we're getting this row here, multiplying it with the first column. So one lot of 27 times one lot of 18 times one lot of 35. That's just 27 plus 18 plus 35, which is adding this vertical column here, and that will produce 80. Same thing again for the dogs. 9, 15, and 6 will give us 30. Same thing again for foxes. Same thing again for the rabbits, and we'll get 90 and 177 respectively. So, one information about matrix S is given by the product A times S. Well, just like the other matrix, we're not finding out how many animals were cited all up. In this case, we're getting the amount of sightings from each animal, or for each animal rather, regardless of which person cited or how many each person cited. Okay, so all up, 80 cats, were cited, 30 dogs, 90 foxes, and 177 rabbits were cited from those 3 park rangers. Okay, go ahead and copy those relative answers down. And that will be it for this exercise 5F, applications of matrices. Go ahead and check your logbook or log sheet to see which questions you have to do for 5F. And then again for tomorrow's class, there'll be 2 more videos to check out. Until then, work on 5F. I'll see you guys soon.